In the previous video, we wrapped up by explaining the connection points of FDCs in various sprinkler and standpipe systems. In Part 2, we'll continue building on that foundation. We'll cover the number of FDCs required, pipe sizing requirements based on NFPA 13, NFPA 13R, and NFPA 14, the proper placement of check valves, acceptable FDC locations, required clearance, and the signage standards you need to follow. Under NFPA 14, fire department connections for standpipe systems are required to be sized for the highest system demand. Sections 10.7.1 and 10.7.2.1 of NFPA 14/2024 specify that at least one FDC must be provided for each vertical zone of Class 1 or Class 3 standpipe system. Some standpipe systems are divided into different vertical zones in order to control the pressure. For these standpipe systems that have multiple vertical zones, NFPA 14 requires a separate fire department connection for each zone. However, there's an exception. If a zone is located so high above street level that it's beyond the fire department's practical pumping capability, then an FDC for that zone is not required. In a high-rise fire, every second counts and access matters. Imagine arriving on scene with limited reach, blocked access, or a single fire department connection tucked away on one side of the building. Can that one connection really support a full-scale firefighting operation? According to NFPA 14, the answer is clear: no. For high-rise and large perimeter buildings, the code demands more. According to Section 10.7.2.2 of NFPA 14, a minimum of 2 FDCs must be provided for each zone in high-rise buildings, as well as in buildings or connected structures with a perimeter exceeding 900 feet. In large buildings, it's common to see multiple fire department connections installed at different locations. When a facility is served by private fire service mains that feed standpipe systems across a wide area, additional FDCs help ensure the fire department can effectively pump water into the system from multiple access points. These connections improve operational flexibility and reduce delays caused by obstacles like parked vehicles, damaged hose threads, or debris in the intake piping. These connections must be located on opposite corners of the building, positioned as close as possible to fire department vehicle access. If opposite corners are not feasible, the FDCs should be separated to the greatest extent possible. In addition, fire department connections be clearly visible and recognizable from the street or the nearest point of apparatus access. And finally, FDCs must be located within 50 feet of the street or the closest fire department access point. Section 10.7.3 requires one 2.5-inch inlet for every 250 gallons per minute of system demand. This means the FDC must be proportioned to match the calculated flow demand of the standpipe system. The maximum number of inlets depends on whether the building is protected throughout with automatic sprinklers. For buildings fully sprinklered to NFPA 13, the maximum demand is 1,000 gallons per minute, which equates to 4 2.5-inch inlets. For all other buildings, the maximum demand is 1,250 gallons per minute, requiring 5 2.5-inch inlets. In combined systems, where the water supply is shared between the standpipe and sprinkler system, the FDC must be sized for the greater of the two demands, either the sprinkler demand including hose stream allowances or the standpipe demand. In most cases, the standpipe demand governs. Combined systems follow the same maximums, 1,000 gallons per minute or 4 inlets for fully sprinklered buildings, and 1,250 gallons per minute or 5 inlets for all others. For example, a standpipe system with a 1,000 gallons per minute flow demand would need 4 inlet connections. According to Section 11.2.1, the pipe size shall be determined by hydraulic calculations. In addition to the standard 2.5-inch inlets, NFPA 14 permits the use of large diameter fire department connections. These couplings, typically 4 or 5 inches in diameter, are designed to accommodate higher flow rates, up to 500 gallons per minute for 4-inch inlets and 750 gallons per minute for 5-inch inlets. Unlike traditional threaded connections, these use a quick connect mechanism. Tabs are aligned with slots and rotated just a quarter turn to lock in place. They offer faster hose deployment and improved flow capacity for demanding fireground operations. It must be noted that both NFPA 13 and NFPA 14 permit the use of listed large-diameter quick-connect threadless fire department connections, typically 4 or 5 inches in size. However, neither standard gives specific guidance on how to size these connections in the same manner currently provided for the standard traditional 2.5-inch fire department connection inlet. According to NFPA 13, 2025, Section 16.12.6.1 and NFPA 14, 2024, Section 992, a listed check valve must be installed in each fire department connection and located in an accessible position. The recommended practice is to place the check valve so that the length of non-pressurized pipe in the FDC supply line is minimized. Each separate water supply should connect on the system side of a check valve. This arrangement allows pressure differentials between municipal supply, fire pumps, pressure tanks, or fire department apparatus to properly feed the sprinklers. The highest pressure source will supply first until its capacity is reached, after which the next highest source takes over. The check valve ensures that higher pressure supplies do not backflow into lower pressure ones. According to NFPA 14, Sections 9921 and 99211, the check valve in a fire department connection must be located as close as possible to the FDC inlets in an accessible location and not in a place subject to freezing. While the standard emphasizes accessibility and freeze protection, it does not specify an exact distance from the wall. In Chapter 5 of his book, Standpipe Systems for Fire Protection, Professor Kenneth Eastman notes that most designers follow a practical guideline, placing the check valve at least 4 feet away from the exterior wall. The actual distance needed depends on the expected outdoor low temperature and the building's interior heating. Rather than performing complex convective and conductive heat transfer calculations, designers rely on this general rule and ensure the valve remains accessible for inspection and maintenance. Section 994 of NFPA 14 requires an approved automatic drip valve to be installed at the low point between the check valve and the fire department connection, but only in areas subject to freezing. This valve must allow drainage without causing water damage. We've already covered drip valves in detail under the topic drains in our previous videos. If you'd like to learn more, feel free to check out those episodes on the NSVCad YouTube channel. It's very important to note that, according to Section 16.12.6.2 of NFPA 13, there shall be no shutoff valve installed in the fire department connection piping. This ensures that the FDC remains unobstructed and fully available for emergency use. Any valve in this line could restrict flow or delay firefighting operations, which is why the standard strictly prohibits it. The fire department needs a reliable water source to pump into the fire department connection. In urban and suburban areas with public water supplies, the location of fire hydrants often determines where the FDC should be placed. According to NFPA 14, the FDC must be located within 100 feet of a fire hydrant connected to an approved water supply. However, the standard allows greater distances if approved by the authority having jurisdiction. The challenge arises in areas where no hydrants exist, such as remote or private properties. In these cases, the standpipe designer must obtain special permission just to determine a suitable FDC location, since NFPA 14 is written with hydrant-based systems in mind. However, unlike NFPA 14, neither NFPA 13 nor NFPA 13R includes specific requirements for the distance between the fire department connection and a fire hydrant. Section 16.12.5.7 of NFPA 13 simply states that the FDC must be located at the nearest point of fire department apparatus accessibility or at a location approved by the authority having jurisdiction. So while NFPA 14 ties FDC placement to hydrant proximity, NFPA 13 and 13R focus more on operational access and AHJ approval, without referencing hydrant distance directly. Now the question is, at what height should the fire department connection be installed? According to Section A 1612 of NFPA 13, 2025, and Section 996 of NFPA 14, 2024, fire department connections should be installed between 18 inches and 4 feet above the adjacent grade or access level. They must also be positioned so that hose lines can be easily and conveniently attached, without obstruction from nearby objects such as buildings, fences, posts, or other fire department connections. According to the International Building Code, the fire department connection must be immediately accessible, with a minimum clear space of 36 inches on all sides and 78 inches vertically. This clearance must account for nearby buildings, fences, railings, and landscaping. The FDC should also be positioned so that hose lines from the closest hydrant do not obstruct fire apparatus access roads, although in practice this is not always possible. By contrast, NFPA 13, NFPA 13R, and NFPA 14 do not specify clearance dimensions. Instead, they simply require that hose lines can be readily and conveniently attached without interference from nearby objects such as buildings, fences, posts, or other fire department connections. Here's the critical point to understand. Signage at the fire department connection is not optional, it's essential. Firefighters must know exactly what the FDC is supplying, whether it's a standpipe, an automatic sprinkler system, or both. According to the requirements of NFPA 13 and NFPA 14, the sign must clearly indicate the designated services, and it must also show the pressure required at the inlets to meet the standpipe system demand. However, if the system demand pressure is less than 150 pounds per square inch, this pressure indication is not required. Why is this so important? Because fire department procedures typically assume a default pump pressure of 150 pounds per square inch.